Alright, so now that we've covered the ways you can add some dynamics to some building, let's go into how it actually gets accomplished. The above features are often required to be defined in one or more of three places. The first is the P3D model itself. A lot of times a model is going to need to have some properties defined for it in order for it to function properly in game. You will find that sometimes this can work. Sometimes the models can work without these parameters defined when they're dropped as a vehicle in an editor. But if they're used as an object on a terrain, they have to have the information built into the model. If they don't, they will not function properly, and you'll be confounded as to why. So oftentimes the information needs to be defined in the building itself. So if we look at, for example, in the geometry here for this building, we have a property name called map, and the type is defined as a building, a class, property name class, and we have to tell it that it's a house. Damage, in this case, because it's a heavy bunker, we are pretending that it does not get damaged. And then SB source is the shadow volume. That tells it how to generate its shadow, because we have a shadow volume LOD here, which tells it which parts are exposed to the sun and or cast a shadow. Whereas without that, it would kind of make up the shadow as it could. And then here it's told to prefer the shadow volume 0. In many cases there are two shadow volumes, a high and a low res one. This one there's only one, so it's kind of a moot point preferring that one. So that's one example of where some stuff can be placed. It has to be defined as properties in the model. And then in view geometry, in memory, you'll have some other things that might need to be defined depending on what you're accomplishing with the model. So you might need to define some of the stuff in the P3D model itself. Then there is a file that's called the model.cfg. This is a text file, and you can edit in any text editor. It defines bones from a model in order to create a skeleton that can be animated according to animation sources that already exist in the engine, or ones that you have custom defined based on available sources. Then there's the Config.cpp, which is another text file. There are lots of plugins available for Notepad++, and I'm sure other text editing suites that make editing the configs a lot easier and more intuitive. And if you're familiar with light code editing, it's fairly straightforward. But let's take a quick look at some examples of both of those. So here, we have both in order to configure all of our buildings. So this is the model.cfg, and this part of it is always included in every model CFG, and it just essentially says this is a class of config skeletons, which means we're configuring skeletons for models here. You introduce the class default, which is allows you to then create your own classes based on default. So the default doesn't have any parameters really defined, but then when you go in to define your own, you then add the parameters you want. So I don't want to look at too complicated of one because they can obviously get pretty complicated, but I kind of do want to look at a fairly complicated one just for sake of getting some exposure right off the bat. So since we looked at the dumb istan OLES damage, let's look at that for the model config. And what we'll see here is There we go. So you can see here, this is the skeleton config, and this is the actual physical model itself, and we're looking at the first level of detail. These numbered layers here are all referred to as resolution LODs. So we're in the first resolution LOD, which is the most highly detailed one. And then in here we have our named selections. So you'll start to see a correlation. So here is awning, and you can see we've defined a bone called awning. Because, as you'll see here, awning is not attached to anything. However, down here, awning is attached to roof 1. So when we look at the model and we look at roof 1, you can see if that were to break, it would tear down part of this. And that's why the two bones are linked. So here, you define all the bones. You've got awning, roof, roof 2, 3, 4, wall 1, 2, 3, 4, 5, 7, 8, door 1A, shutters, and this essentially tells the engine that this is the model. It has a skeleton that has all of these bones, and then after you're done defining all your bones, you go down and you create the animations. So underneath, we've closed off the config skeletons. We now have config models, and again, we're calling some core classes here: rotation, translation, and default. And then you get into your own, which, as you can see, can get really involved and really long. But a lot of it is just copy and pasting of the previous one. So once you have it set up, it's not so hard. So let's find dam. Alright, so this is right here. And so in the model config, you call the skeleton name that we created up top. You define what sections it has. This is sort of out of scope of what we're talking about right now. And then you create some animations, and it defines what bone is being moved, and then the conditions under which it's being moved. So this is just to get the doors and the shutters to open. This is to get glass to shatter. And then that was the wrong damn model. There we go. So again, doors, shutters, there's no glass in this one, so nope, that's the wrong one too. Yeah, there we go. This is the damageable one. Okay, so there's the door to get open, and the shutters, and then this door is actually also destructible, so if you hit the door, it'll be destroyed. That's all configured here. And then the same thing. The wall is the type of animation is hide, and it essentially this essentially tells the engine that if this part gets hit this many times, hide it. And that's pretty much it. Here's the damage classes, which are a little bit more complicated, but it's essentially the same thing. You have a source, which is the hit wall, and the section that it removes, and this ends up producing the effect of damage. So that was the model config, and then let's look at the Config.cpp for the same thing. Actually, let's make it really easy and just search for the same one in all of them. So I should close. Alright, so then we look in the Config.cpp, and you have to define the building separately. So what we've done in the model config is all we've done is defined the skeleton of the model and created some animations that the model is capable of performing. Then inside the Config.cpp, you then configure the model to be placed in game. If there are no animations or the model doesn't have a skeleton, all you need is a config.cpp. So for a very simple object that doesn't do anything, a completely static object with no animations, you don't need a model config. You only need a config.cpp, which essentially names the object, tells the game where to find the actual P3D file, and then defines some characteristics about the model itself so the game knows how to treat it. Here is the destruction effects calling a ruin class, and you can see here the name of the ruins model, and then again the config CPP redefines and organizes how those animations that we created and how those bones we created in the model config are used in the game, and by what, and by what. For example, the door, its menu is triggered by a user's presence. It takes this long for it to pass through its entire animation phase from open to close, and here's the state it is when it initializes. So when it spawns a building, it's in a 0 state, which means the door is closed. So you can have that random. You can then take this same parameter in scripting and then change it on a mission to randomize whether it's open or closed. But that's also a separate topic. But so the config.cpp essentially is a lot more complicated, but it's just because it's really giving line-by-line instructions to the engine on how to handle the model in combination with the animations, in combination with the skeleton, for use in game. So once those three areas are fully defined, then you end up having a working model. So now that we know the components of a working model, the P3D itself, the model config, and the config CPP, let's focus in on the models and what those levels of detail that I was talking about before are. So, as mentioned before, the numbered LODs, 0, 1, 3, 5, 20 in this case, those are the resolution LODs. And essentially what you want is in the lowest numbered LOD, you have the full model in its highest detail. Then you reduce the detail in each progressively lower LOD in order to have a more and more efficient model until you get down to basically a box. So let's look again at that, and you see here on the first level of detail, it's 1200 points, 2050 faces. You go to the second one, it's 940 points, 1600 faces. Got a third one, it's 573 with 900. Down again, and it's down to 292 and 306. And then you get to 20, and it's basically approaching a box at this point. 215 faces, 212 section. 215 points, 212 faces. So those are your resolution LODs, and the engine, picks and chooses which ones of those to use in order to save performance due to the high number of objects in game. Then you have your shadow volume LOD, which is these are just some basic, real rudimentary and basic rules that I've included here. It has to be within the model and has no textures at all. All faces must be closed, and you ideally want to have two, one for the closest LOD and one for the farthest LOD. Then you get into a geometry LOD. All of the shapes in the geometry LOD have to be closed and convex. This is the LOD that stops units from moving through an object. So your character model, for example, will walk right through a building that doesn't have a geometry LOD. When you're done with it, when you're done making adjustments to the geometry LOD, is very important. You have to select all So all, and then select all, and then go to structure, topology, and find components. If you don't do this, they won't be discovered and they won't work properly. Then you have your memory LOD, which allows bones, buttons, door lights, Alice module information, AI information, a lot of stuff to be stored that can be used for scripting, or that's used by the model config or the Config.cpp in order to further define certain points or areas on the model. The roadway LOD is flat planes, and it defines where characters can walk and the sound it makes when you walk on it. You can define the textures and the sounds that it makes when you walk on it. All faces have to be facing up, otherwise your character will fall through. There's a little link here to a good tutorial by APS-NAT that is how to properly set up surfaces, config surfaces, because if you make a custom one, you also have to define that surface in a separate file, which again, a little bit out of the scope of this tutorial. Then you get into paths. The paths define how AI interact with a building. So you have in positions, which are in one, in two, etc. And those are the points where AI can begin walking from an exterior area into your building. And then position 1, position 2, position 3 are all places that they stop or can go or in patrol. Hit points defines destructible points of a model, as I showed you in the destructible OLES building. View geometry. This is what can and can't be rendered. So all components, again, must be found. Essentially, if you ever see trees disappearing outside of a building when you're looking out a doorway or out a window, it's because the view geometry isn't configured properly. Then you have fire geometry, which I went over a little bit, which defines the materials for penetration, and the thickness of the material will influence the density. This is on a model level, so if you make a plane of glass that's a little bit too thick, even though it knows it's glass, it will not penetrate the glass. Same thing again with all the geometry LODs. You have to find the components when you've made alterations to it. So you go to structure, topology, find components. I'll just show you that real quick. So if you're in the geometry, you'd select all, and you go to structure, topology, find components. That's it, and that one little step will be the difference between it working and not working. I do not want to save my changes. So yeah, and then new for ARMA 3, they have the GeoPhys LOD. For this, we just copy and paste the Geo or Fire Geo LOD, and it just this defines how the object interacts with physics, other physics objects in the world. So if you throw a grenade, it will not fly through the building; it'll bounce off the building, or etc., etc. So and then at the bottom, we've got some references here. You've got model config reference by on the Biki. You have named selection translations from the Biki. Model class named properties, how to animate, vehicle config. These are all very useful, but really the most useful resource for a modeler is going to be the PMC Tactical Wiki or guide, and you can just quick Google search, and it's right there. So. This is PMC Tactical. Please consider donating. They are really, really amazing and have an unbelievable library of resources for modders here. But so, one of the great things to do here is you just do, as I outlined in another video, you just type in the word you're searching for, and then site colon and that site, and you'll guaranteed every single time you look for something, you will find just really, really detailed, great tutorials and forum posts and everything that you need to find on there. Most of the stuff that Milkman has managed to get working for the SMD buildings has been a direct result of reading PMC Tactical. I know he used their glass breaking tutorial. I'm pretty sure that's what he used for the animated destruction as well. So, you know, really huge repository of information available there. So please consider donating to them, and you know, any other alma maters that you are you know, that you're using or taking advantage of their hard work on a regular basis, you know, and whether it's financial or just moral support. They would all the modders love hearing positive feedback on their works and whatnot. So, you know, give them a thumbs up on their videos, post some positive on their forums, forum posts. You know, just keep them encouraged. So thanks again for watching, and this should pretty much take me to the end of the pre-prepared tutorial. So next I'll be able to start getting into some actual examples of modeling some assets. So thanks again for watching, and I hope you enjoyed.